What if robots no longer needed humans to exist? Imagine a world where machines reproduce, building, upgrading, and multiplying on their own. Machines already build our cars, perform life-saving surgeries, and even chat with us like old friends. But there's one thing they can't do yet. The ability to create life, or at least themselves, has always been our domain. But what happens when robots learn to multiply? Could they build a better future for us, or one without us? Before getting ahead of ourselves, it's important to remember that the concept of self-replicating machines isn't new. In fact, it's as old as robots themselves and dates back to the 1940s when mathematician John Von Neumann created a theoretical model he called a universal constructor. He envisioned a machine with three parts: a description that held the blueprint of the new machine, similar to the way our cells have DNA, a constructor that could read and create the machine, and a universal copy that could make copies of the description. Despite further research on the viability of his self-replicating machine entering the 50s and 60s, Neumann couldn't build a practical machine. However, his research set the foundation for artificial life to reproduce. For example, in the 80s, NASA conducted a summer study on the possibility of creating self-replicating lunar factories. As one of the scientists put it, self-replication is the only robust approach to space exploration, as it would inevitably save America billions of dollars in resources if robots in space could extract the materials they need to make clones. That's not to say it could build a new spacecraft from scratch while out in the solar system, but these robots could, in theory, convert near-Earth objects like asteroids into an antenna. On the other hand, larger-scale projects like a self-replicating factory on the moon could create other factories that mine more raw materials, effectively doubling production without spending a single dime. It would be like creating a clone of yourself that could help you get your job done twice as fast. As cool as that would be, we're not likely to see such innovations from NASA anytime soon, as their Jet Propulsion Lab, JPL, labels the idea as a moonshot because of how far-fetched it is. So what about here on Earth? Surely it would be a lot easier to create a self-replicating robot here than in outer space. Well, when 3D printing technology stepped into the scene in the 2000s, it became easier for robots to create more complex structures, like building components, vehicle parts, and even bigger robots. As a result, modern manufacturing companies now use this technology to make prototypes of new products and create custom tools for their inventories. Also, in aerospace and the automotive industry, 3D printers create lightweight spare parts. However, researchers at MIT are taking this concept a step further by automating the process and combining it with robotic parts that can assemble the printed components. In other words, they're building robots that could create a fully functional race car, a new airplane wing, or even another robot without human input. As a result, these fully autonomous, self-replicating printers and assembly systems could completely change our entire construction and automobile industries. In fact, such an invention would have a ripple effect across all sectors, as even in healthcare, 3D printing helps surgeons practice complex procedures on three-dimensional models of a patient's organ. If we're going to crack the code for these systems, it'll likely be by creating advanced voxels, which are tiny but identical volumetric 2D pixels. For context, earlier voxels were purely mechanical pieces, mere building blocks, with no use other than to provide structural support. However, ongoing research at MIT to produce active voxels with power and the ability to transfer data from one unit to the next means that they won't just be static components of a flat material. These new subunits will be the building blocks of structures that can bear load, making them useful objects that can lift, move, and manipulate other materials. And because these voxels could communicate with one another, they could print more copies and join them from end to end till they form a different structure. Unfortunately, there are still a few kinks to work out in the process. Gershenfeld, one of the researchers on the project, highlighted that the system is likely to become inefficient the bigger the structure gets, because the assembler machine would have to follow a longer path to put each piece in the right place. They also have to work on creating an algorithm that helps these self-replicating machines make the right choices throughout the entire process. In other words, they essentially have to put checks in place to ensure you don't end up with a sandwich when you order a burger. After all, we share 98% of our DNA, our biological blueprint, with chimpanzees. That means a small mistake in a robot's ability to read instructions could result in an output you don't want. If they can hack it, we could see assembly lines of autonomous robotic arms successfully making more robots. Taking it a step further, it might even be possible for self-replicating robots to create organic life. In 2020, a research group made waves when they created tiny, programmable living robots from frog cells called xenobots. These living machines could produce their energy to walk, swim, and even decompose like biodegradable matter organisms. However, recent research showed that these xenobots could do more than move. They can also autonomously self-replicate. According to Dr. Douglas Blackiston, one of the biologists and senior scientists on the team, what we are showing here is not something that any natural system on Earth does. It's not producing progeny directly, but rather it's collecting material and building copies of itself. We don't see any organisms on Earth that do this. It would be like if humans could extract carbon, hydrogen, oxygen, and other elements from the air and ground and put it together in the correct order to create another human. And while these living robots are still a long way from building something so complex, it's impressive that they're capable of making new bots with the same ability to reproduce up to 5 generations. But it's been 8 decades since von Neumann first proposed his theory of a self-replicating machine, and for the most part, building robots today still requires human intervention. So, are modern robots any closer to cracking one of the most basic biological processes? The short answer is yes. In December 2024, researchers from Fudan University in Shanghai, China, published a groundbreaking study on AI's ability to replicate. With remarkable success, 2 large language models from Meta and Alibaba shocked us by creating separate copies of themselves autonomously. In one of the scenarios they explored, researchers designed the AI model to detect any shutdown attempt and respond by creating a functional replica to ensure its survival. Another situation where the LLMs were able to reproduce was when the researchers programmed them to make a clone that could make a clone, creating an infinite feedback loop. So how did they do in the experimental trials? In at least 50% of the tests, both models could create a live and separate copy of themselves, with some trials even having a success rate of up to 90%. If these LLMs can successfully replicate themselves in peer-reviewed studies in the future, it would prove that modern AI is already capable of making functional copies of themselves without our help. Imagine what that would mean for our society. According to one of the researchers who worked on the study at Fudan University, successful self-replication under no human assistance is the essential step for AI to outsmart human beings, and an early sign for rogue AIs. After all, thanks to modern automated assembly lines, machines already have the power to put themselves together. Now, with the intelligence to make live copies of themselves, there's nothing stopping them from writing their own programs in an infinite loop to produce more robots that could potentially overpower us. With AI systems like Google's DeepMind already designing better AI models without human input, that reality may not be as far-fetched as you'd expect. The team shared that their system, AlphaDev, is capable of identifying its weaknesses and finding new ways to improve its algorithm. It's kind of like trying to become a better chess player by playing against yourself. This process, called reinforcement learning, means that the AI system can improve itself beyond its original human design all by itself. Can you imagine if AI replication became fully autonomous? While it could save us a lot of time and money in production across different sectors, it could also get dicey really quickly. For starters, once AI can replicate itself, there's a higher chance of it becoming unpredictable. In comparison, the human body has a natural system that detects and destroys mutated cells with errors. However, a self-preserving and self-replicating AI could theoretically make copies of itself when it detects someone trying to destroy it. In such a scenario, it could also initiate a continuous loop of reproduction like a cancer cell that multiplies with each new copy. And if we lose control of the mutated AI system, it could easily turn on us by causing physical harm, spreading misinformation, or even developing weapons of mass destruction. On a less melodramatic note, even if new AI systems don't suddenly go rogue and demand the end of humanity, they could still be bad for us. Such technology would inevitably require large computing power and energy resources, limiting some people's access to it. The growing use of AI is already accelerating our environmental problems, from AI servers that produce electronic waste to data centers that require large amounts of water to cool down their systems. Self-replicating robots that require more power would worsen a bad situation and could expose us to faster climate change and entirely new levels of pollution. So as easily as it could turn our world into a robot-automated utopia, it could just as easily be catastrophic for us. It's already pretty obvious that if AI isn't capable of self-replicating yet, they will be soon. The question is, how likely are they to go rogue once they can reproduce without our input? Let me know what you think in the comments section below. But if you want more unfiltered truth about AI, synthetic humans, and the future they're hiding, subscribe for more updates. Stay skeptical, stay curious, and remember, the future doesn't just happen, we build it.